So can you see the slides?
Mhm.
Hello?
Yes.
Yeah.
Yeah,
Okay.
you
So,
can start, Patricia.
okay. Thank you, Rajesh. Hello, I am Patricia Neri, and I am the 2026 president of the practice section of Informs. For the practice section, it is important to join forces with the Analytics Society to present this webinar. The practice section is committed to deepening engagement and creating meaningful opportunities for students and early career professionals. These opportunities include webinars, the monthly networking happy hour, and ECPN participation, Early Career Practitioner Network participation. I will briefly describe who we are. Then we will have the 2025 Data4Good Analytics Competition winners present their work, and they will receive some question and answers. And finally, Matthew will talk about Data4Good and the many, many benefits of joining the competition. Okay, now let me share another set of slides. Okay, this is the Informs practice section. And you may be wondering, well, who are we? Well, we are a lifelong community of full-time and part-time practitioners. We are consultants, industry analysts, academic researchers. The very important part that describes us is that we engage in applied work. So we put together theory and practice, and we foster collaboration, knowledge sharing, like this webinar, and professional growth. I love that our members span many corporations, government entities, nonprofits, and industries, which include healthcare, finance, logistics, manufacturing, technology. So anywhere where you can apply analytical methods from traditional ORMS techniques to advanced AI approaches, that is where our members are. So being a member of the practice section is very interesting. Being the president is a little bit challenging. Okay, how do we achieve this main goal? Well, we support career learning. We have connections, networking through webinars, industry case studies. There are many, many YouTube videos that are describing the Franz Edelman Award, that is a prize given for the advance of analytics, operations research, and management sciences, the UPS George Smith Prize for teaching the practice of operations research, and the Daniel H. Wagner. This is a prize for excellence in the practice of advanced analytics and operations research. These prizes were very important when I started my career, and I wanted to figure out about what can I do with analytics? What are our methods? How can I talk with my boss and the C-level executive? So if you want your career to flourish, use these resources. There are articles, there are YouTube videos, you can email members of the community. Also, something that is really very nice is that we are having a networking happy hour once per month where everybody is welcome. And these are very good opportunities for networking. You can see more at our website, and I invite you to know more about the practice section of Informs. So now we are going to have our winners of the Data4Good do their presentation. So you can just start sharing and give your presentation.
Good morning, one and all. Thank you for being here today.
Honestly, it feels like just 3 months ago we were presenting the same solution in Washington, D.C. during the Informs Data for Good Competition finals, and presenting the same today here with the Informs Analytics Society and Informs Practice session as the national champions actually feels very rewarding. So, thank you so much for this opportunity. Before we begin, let me introduce our team to you all. I am Dheerusha Tiwari.
Hey everyone, I'm Chinmay Deshpande.
I'm Siddharth.
Hi everyone, sorry. Hi everyone, I'm Kazi Ahmed.
And we will be presenting our solution detecting misinformation in AI generated learning content today. Before we dive into the technical solution, Before we dive into the technical solution, we really want to acknowledge what the Informs Data for Good competition gave us beyond the winning title. One of the most exciting parts was the recognition that followed after the competition. Our work was acknowledged and published in the newsletter of both Spear School of Business and College of Engineering, Architecture and Technology here at Oklahoma State University. Not only that, we got the opportunity to present our work at events such as SAS Analytics Conference, and today we are here at the Informs practice session. So thank you so much, Informs Data for Good, and all the stakeholders involved in this competition. We'd like to begin our presentation with one question that we asked even in our competition. Any idea which telescope has captured the first images of a planet outside our solar system? We actually had this question and we simply asked ChatGPT, like a question that we just picked out of curiosity and asked ChatGPT. So it actually replied Hubble Space Technology, Hubble Space Telescope. And then we were like, is it really Hubble Space? So we then asked, isn't it European VLT, European Very Large Telescope? And in reply, ChatGPT actually said, yes, it's actually European VLT, not Hubble Space. So that actually made me feel a little bit better about myself, that I'm actually still smarter than AI. But then if you actually see in real world, this same question cost Google $100 billion loss in the market when it promoted the same AI assisted chatbot and it provided a wrong answer. Now translate this into education industry. A lot of students today use Perplexity, ChatGPT, and a lot of AI platforms. But as a research conducted in Purdue University, 52% of the answers generated by ChatGPT are actually misleading. And in fact, these AI platforms fail in two different ways. One is very straightforward. They simply provide factually inaccurate answers. The second one, they sound very convincing, very confident, but the answer is rather contradictory or unsupported. That's why we asked ourselves, how can we achieve at least 95% accuracy for AI-generated answers, and how can we integrate a verification layer that detects and corrects these wrong answers before we actually deliver it to the students? Now, we did mention about accuracy, but we also wanted to know what does the industry want. As per a survey done by Microsoft, the AI leaders in education industry basically want a system that is secure, that is within the budget, that is scalable, and can finally be integrated with the existing system. So now that we understand what was our problem, what is the need of the industry, we try to translate our business problem into analytical problem. So we had three questions to address. The first is, can we automatically classify answers into contradictory, irrelevant, or factual? The second is, what signals help us to distinguish good answers from the bad ones? And finally, the third is, how do we minimize error rates so that incorrect answers do not reach students? For this, we were provided with Data4Good data set, and we actually split the data set into 21,000 of training data, again 2,000 of test data. We had assumed that the data that were provided to us actually reflects the real world business behavior. And finally, to evaluate our results, we used a different kind of metrics. Some of them were overall accuracy score, balanced accuracy score, and finally error rates. Now, throughout the competition, we were involved in several kind of informs workshop and certification. So as a part of our brainstorming and problem solving process, we made sure that we actually followed each and every steps of informs. So to begin with data understanding, with whatever data that we were provided with, we understood that AI is correct. Well, but most of the times, in fact, 17% of the time, AI provides either contradictory or irrelevant answers. So our focus throughout this project was to minimize that 17% of the time. Similarly, I think we all have done it. We simply send a very half-baked question without any context to ChatGPT and hope that we get correct answers. And in fact, when we do so, when we provide a question without any context to AI platforms, that's where they start guessing. And in our data, we had 9% of the records that were actually missing context. Thirdly, we know that not having a context is a problem. We also knew that contradictory answers are a problem. But when we combined both of these together, it became a high-risk problem. So we found 146 cases of those which we actually highlighted as highly critical cases. So we saw all these three problems in the data provided, and we thought about how do we resolve all this. So to begin the process, I'd like to call on Siddharth.
Right, thanks, Dheerusha. So now that we have an understanding of the business problem and the kind of data that we are working with, the next step would be to turn this raw data into something that models can actually learn from. From the data that we had three text columns as input. That is the context, the question that is asked, and the answer that the AI is generating. And finally, the label, which will be factual, contradiction, or irrelevant. The good news for us was that the data size was relatively clean. Even then, we did perform some pre-processing to remove unknown symbols and noisy characters from the text fields, just to make the pipeline more consistent. Next up, we split the data into training, validation, and holdout sets, so we could properly train, tune, and evaluate our models. Now, here's an important thing to remember, that models won't understand text the way we do. So they would only understand numbers. So the next stage was label encoding and feature engineering, where we transformed these text columns into numerical representations compatible with machine learning models. From EDA, we saw two major challenges. The first challenge was class imbalance. We had far fewer non-factual examples compared to factual ones. And if we are not careful, models in these situations tend to learn the easy shortcut, that is predicting factual most of the time. So to counter that, we generated additional contradiction samples by introducing negations and modifying numerical values wherever applicable. For example, the answer could be today's year is 2026. We would change the numbers to random numbers, and then the label would become contradiction from factual. The second challenge was model compatibility. Different models can only process a certain amount of text because of the context window limitations. So instead of feeding the entire document, the entire context, we ranked sentences based on relevance and retained the most important context and truncated wherever we found it necessary. All of these steps helped create a strong and more reliable foundation for the modeling process that we will be following next. So once the data pipeline was ready, the next question became, how do we actually represent this language effectively? We first started with a more traditional setup. We converted text into static embeddings and trained classical machine learning models. By static embeddings, I mean converting tokens into numbers. So captures would be one, semantic can be two, and so on. If every word can be a number. And honestly, this gave us a pretty solid baseline, but eventually the performance plateaued, and that pushed us to think deeper about the representations itself. So let me ask you a thing. When I say the word bank, what do you think of it? It could be a financial bank or a side of a river. The word in these cases is identical. The meaning changes only because of the context. And that was the core limitation of static embeddings. They treat words more or less the same, regardless the surrounding context. For example, if I have a sentence, I went to the bank to encash some money, and I went to the bank to fish. In this case, the bank should have different representations given the word surrounding it. So then we move towards transformer-based models, which generate contextual representations instead of the fixed one. In other words, the model now understands the meaning based on the surrounding words and relationships within the sentences. And because the representation learning and classification happen together, we observe a significant improvement in accuracy. And we were able to put that 99% on the leaderboard that we had for Data4Good. And now the important question remains, how much improvement did we actually achieve? Like this 99%, what does it mean? Is that enough? I'll hand it over to Chinmay, who will walk us through the results and additional announcements that we explored later. Over to you, Chinmay.
Thank you so much, Siddharth. So like Siddharth mentioned, we tried various ML-based models, and what we finally found is transformer-based models is what gives a higher accuracy, and we were able to reach an accuracy of 99%. But we understand that even those 1% of the errors that we have can have a significant impact on educators and students alike. So we took it upon ourselves to investigate those 1% errors, and what we found is those errors typically fall into 3 different kinds of categories. The first kind of errors that we received were from the no context cases, where we only have question and answer. Second were the kind of cases where it was difficult for the model to judge the semantic relationship between the question, context, and answer. And finally, there are third kind of cases where there's a logical inconsistency in the context, because of which the model is performing poorly. So for these 3 different kinds of cases, we proposed 3 different kinds of solutions, which came together as a single architecture. So let us look at each case individually and see how our solution tried to solve those problems. So let us start with the no context cases. To better understand this, let's go through an example. Let's say the question is Pluto a planet? Now, I'm sure most of us know from our understanding that Pluto, in fact, is not a planet. In 2006, Pluto was reclassified as a dwarf planet. And so what we are going to look at is, we are going to look at this example. We are going to see what an AI platform answers, and we are going to see how our models try to verify these answers. Now, in this case, the question is Pluto a planet? And we don't have any context. The answer given is no, Pluto is not a planet, which is factually correct. But how does our model verify it? So what happens is, our model identifies that this is a case of no context, and this routes it through a no context classifier. Now, what is a no context classifier? It is a classifier which is specifically trained on cases of only question and answer, no context. And we improved this model using a method called targeted oversampling. Now, after the response goes through this model, it sees that Pluto not being a planet is a factually correct answer, and that is what the final classification that we receive. So that is a no context case. But what if we add a context to this case? That is the case of semantic nuance. So let's try to change the example just a bit. So in this particular case, what we see is there's an additional context provided, and it says Pluto does not meet the scientific definition of a planet. It does not give a direct answer as a yes or a no, but it gives a context, and it is the job of our model to look at this context and then through it understand the semantic nuance between question, context, and answer, and then give a final classification. So what happens is, the model identifies that this is a case of question with a context. It goes to a semantics-based classifier, which is trained on context-present records, and it is good at understanding the complex interactions between question, context, and answer. It gives a classification, but we are not just done here yet. This classification or this answer, which is given by semantics classifier, goes through a grounding expert. Now, what grounding expert does is, it adds confidence to the decision made by semantics based classifier. In this particular case, it is highly confident that the answer is correct, and hence it gives the final classification as factual. But what if a grounding expert says it is not confident? Those were the kind of cases of logical inconsistency. And let's look at another example to understand this third kind of error that we solved. So in this third kind of error, what we see is context is now very different. This context is a bit long and has 2 aspects to it. The first part of the context says it is easy to classify Pluto as a planet. That's the first part of the context. The second part of the context justifies why Pluto should not be a planet. These two cases in the same context are logically inconsistent. The semantics classifier is not able to identify this logical inconsistency and says that yes, Pluto is a planet. But we all know that this is the wrong answer. So how do we solve this? What happens is the grounding expert in this case says it is not confident in the answer given by semantics based classifier, and it reroutes it through another layer of inference based classifier. This inference based classifier checks for logical inconsistencies, and if it sees that there's logical inconsistency, it reverses the logic from factual to contradiction, and hence we get a final classification as contradiction. So this is how the three kinds of different layers solve three kinds of different problems. But how do these all look in numbers? So if we look at the test data that we had, what we see is the no context classifier is good at detecting, improves the accuracy by almost 0.5%. For 80%, for some of the cases which have context, almost 80% of them are auto-resolved by the semantics-based classifier. But however, those 20% of the cases which need to go through inference classifier, almost 8% of those cases are flipped to contradiction. All of this together improves error detection further by 4.4% and gives us a balanced accuracy of 99.56%, which translates to an overall accuracy of almost 99.78%. So that is how we try to achieve near perfect accuracy as far as detecting factual contradiction or irrelevant responses. So I must say, our models did learn a lot, but so did we. What we learned throughout this process of developing our models is, first, there's going to be a trade-off between complexity and resources. There would be some use cases where we want to have as much accuracy as possible, and we are willing to give as many resources or spend on as many resources as we can. However, there could be some cases which are able, which would be happy with around 99% accuracy, but which would want to save on resources. So that is an important aspect to keep in mind. The second is we tried various combinations of strings of question, context, answer, and which of these combinations are best understood by transformer-based models. And what we found is a string of question, answer, and context is what works the best. We tried various kinds of keyword matching in order to see if that improves model, but it did not add any good incremental value, and so we did not include it as a part of solution. Finally, for inference-based classifier, we initially started with simple natural language inference, which is low on resources. But what we found it is not able to add any incremental value, and that's why we had to switch to multi-genre natural language inference. So those are some of the learnings that we had, and this is how our entire model looked like. But this is good on paper. How does it actually come to life? For that, I would like to invite Kazi.
Thank you so much, Chinmay. So now that we have a near perfect model, up to this point, we have talked about the data model, then architecture and accuracy. Now, how can we bring this amazing model into life, right? Like by that, I mean, like, how can we deploy, scale, and monitor? And most importantly, how do we ensure that we can trust its reliability per user over the time? So to overcome those challenges, we used Azure. Thanks to Data4Good for giving us the opportunity to do AI 900, where we learned how to use AI applications in Azure. By using Azure, we didn't just build a model, we built a fully connected end-to-end machine learning lifecycle. It's not an isolated step, but a completely integrated pipeline. Everything begins in a notebook. By working within a notebook, we turned our raw data into insights, which basically set the foundation for our modeling. Then we utilized Azure AutoML. By using Azure AutoML, the system takes all of our data and test multiple models. It essentially helped us become smarter and faster, finding the best performing solution among all available machine learning models within Azure. Okay, this is where everything comes together. We deployed our model in Azure ML Studio and exposed it through a secured endpoint. So then we connected that endpoint within our Azure App Service where our backend lives. Next, via Azure AI Foundry, we took GPT-5 Mini and its API and integrated it into our web application. This allows us users to ask any questions and GPT-5 Mini can generate responses immediately. Furthermore, through the Azure ML endpoint, our verification model classifier kicks in. and classify these GPT-generated responses as factual, contradictory, or relevant. Every interaction flows seamlessly from the front end to GPT-5 Mini, passes through our verification classifier, and is sent back to the user within seconds. Okay, after deployment, we don't just hope our model works, we actively monitor everything. By using the Azure monitoring service, we track performance drops, user spikes, and data drift so that we can retain our optimize our model, making the system more reliable for future users. By doing this, we maintain a trustworthy model over the time. Now, this is where everything becomes real. We are incredibly excited and presented our solution before at Johns Hopkins University, our Data4Good solution, fact checker. So remember the question we asked earlier about the telescope where the baseline AI got it wrong? So we asked the same question within our application, and our system instantly classified it as a contradictory answer. This is the power of real-time verification. So what exactly is happening inside our model? A user can ask any questions and GPT-5 Mini generate the answer instantly. Then something powerful happens. Through our Azure ML endpoint, our verification classifier steps in. It evaluates each of the GPT-5 responses and classifies them as either factual, contradictory, or irrelevant. This evaluation occurs in real time, right here, right now, not offline. So by doing this, we transform generative AI into accountable AI. We are not just generating responses and giving responses or answers to students. We are actively preventing them from receiving misinformation. Now I would like to ask Siddharth to explain the recommendation.
Thanks, Kazi. So at this point, the model is doing its job well, but in real educational setting, the goal is detection. It's building a system that stays reliable on both students and as the AI systems evolve. So let me break down what it would look like in practice. First would be human in the loop. Think of it as adding an expert checkpoint instead of fully trusting the automation. For example, if the system flags a biology explanation like cells produce energy directly from sunlight, it just doesn't reject it. It routes it to a teacher or domain expert for review. And over time, these will accumulate and these cases become training signals. So the system keeps learning from the real academic judgment. Second, we will have regular retraining. Educational content keeps changing with new research. For instance, if newer models start generating more nuanced and subtly incorrect explanation in physics, say for example, the Pluto example, the old detector might miss them. So we retrain periodically using fresh AI generated responses. And thus the detector evolves with misinformation itself. Third, we have domain-based tuning. This is where things become critical as not all domains tolerate errors equally. For example, in philosophy, saying that truth is subjective can be debated. Multiple interpretation can coexist there. But in medicine, saying paracetamol can treat bacterial infections it's not just wrong, it can be harmful. So the parameters we discussed in our model can be tuned for different fields. And lastly, having an impact analytics dashboard. So then finally, we move on from detection to understanding how this model is impacting or how the students are getting impacted by AI generated responses. Instead of just asking, is this wrong or right? We start asking, where do students most often encounter this misinformation? Which domains produce high risk incorrect answers? Are students being exposed to unsafe confidence in sensitive topics? For example, if we observe repeated incorrect medical explanations around antibiotics, then that becomes a trigger for curriculum intervention or maybe stricter model guardrails. So this would then create a feedback loop between model performance and educational design altogether using AI. And that's all. That's really the point, I guess. Building trust in what these systems produce using AI for good for education and using data for good. So thank you, everyone.
If you have any questions, please feel free to ask us.
To be clear, the audience, we don't have the facility to unmute the audience, so they have to type in the questions in Q&A box, and then you can answer those questions.
Hey guys, great presentation. I have a couple questions for you. What was the biggest challenge or hurdle you guys came across in this case?
I can actually take it. I think thank you so much, Matthew. You've been one of the very motivating person throughout this competition. So when we started, I think how do we actually translate business problem into analytical or analytical into business? That was one of the most difficult thing. Like models, metrics, you can actually go on Google or simply refer to your textbook and understand those things. But actually having that real world relevance is where the challenge was. And also the other challenge would be, I think, trying to translate whatever we did analysis or data science models into to the audience that are basically non-technical was one of the most challenging part. And I think the informs framework or the workshop that we attended with Data4Good, those were very helpful to help us breeze this translation. If I missed anything, please add on, my team members.
Yeah, I think I will just add another part. So thank you, Dheerusha. You basically said the most of the challenge that we have faced. And the challenge I want to mention about during the modeling part, while we were testing like different models, we were stacking to fixed accuracy score. So we were trying to increase a bit like 1%, but it couldn't increase because all the models that we used were giving like same kind of results. So that's why we had to go through and use a new strategy like hybrid model strategy which improve our score as well. So if you look at the final score of all other finalists, you will see like every one of the team members have like very close scores. So it was very competitive. I was so worried, like everyone's score is so close. I was very nervous before the presentation, but yeah, we won. So yeah.
Yeah. Did all you guys earn the AI 900 certification? Yeah.
Yes,
Good.
yeah.
That's good. That's good.
Mm.
All right. Well, I guess at the end, Rajesh can share any other questions that the attendees have shared. Should we move on to the next part?
Yeah, I think that sounds right.
Okay. I'll go ahead and share my screen. Thank you guys so much. Really, we're just really proud of you guys, and yeah, just I know Oklahoma State it is, and we really appreciate you guys taking time this Memorial Day weekend to share this work. So, all right, let's see here. Need to switch these.
I think I can see a hand raise. I'm not sure.
Oh, I think Patricia has her hand raised.
Yes, I tried to put my question in the Q&A, but I didn't figure out how. So I have one question. How did you identify that deep learning was going to give you a better solution? What I am trying to ask you is, what was your thinking going from just simple embeddings to really deep learning?
Right, so I'd like to take that one. We did try out the traditional models that we had, say linear regression to XGBoost, and which were more focused on the static embeddings part, where we convert the text into numbers and then feed into a linear equation or a decision tree model, somehow like that. But it only gave us about 50% accuracy, or to 50 to 60% accuracies. We started learning how texts are treated currently in the industry, and bird family models really did well in classification for sentiment analysis. Say robota is used for sentiment analysis, sentiment classification. So we started exploring the BERT models for this one and find out that the beta was something that gave out the best results. We also tried LLM as a judge, but it was proving a bit costly for us. So we thought this will be less for processing as well as pretty easier to understand as well, pretty easier to take out what the results are, interpret the results like that. Does that answer your question?
Yes, I wanted to figure out your thinking process. At work, I have done some of this type of modeling, and
Yeah.
I mean the part where one learns that, well, deep learning will give you a better solution is something that everybody will take from this type of work. My other question is, do I have time? To improve error inaccuracy, you showed us the Pluto example. But in the
Right.
real world, one problem is that we cannot identify the inaccurate answers. How do you measure the final accuracy in production? Once that you went to your Azure model and you started getting a new different questions that you had not thought before, that you have never seen before, because that is what will happen in production, right? In the real world.
Right, yeah. So recently I saw that let me just reiterate the question so that I have understood it better. So for the questions that don't have an answer in the question bank itself, how is AI giving those answers correct or not? How would we say that it is correct or incorrect, right?
Okay, so I guess
And
that you continue working with data that you knew, right? So you have your training data set, your testing data set, but you didn't incorporate new contests in your.
new context, no. So we
Okay.
did have a test data set here, so which is what we could test on. But in real world, they might encounter new cases, as you mentioned. So for that, new frameworks are also coming in place, such as ragas and everything, wherein they have scores for different things. Say, for example, it could be faithfulness, wherein we are checking if the answer is sticking true to the context or not. And the next would be correctness, if it is factually correct or not, to some ground truth. So
Yes.
I think it is still in development. We did not introduce it in our thing, but it is still in development that we are trying to identify what all incorrect could actually mean. It could be that it is there in my document, but the answer is wrong. That could be one case. Another case would be it is factually correct. So we have to also identify what the problem actually is. We have to divide different types of problems and come up with metrics that would show us the severity of the problem then. And I think that is something that is still in development overall.
Thank you. It is great to see that you have next steps, that the research will continue, because it's really a very exciting field, right?
Yeah, it is.
Okay,
It is.
thank you.
Those are very nice questions. Thanks, Patricia.
We cannot hear you, Matthew.
All right. Yeah, just my first question. Can you guys see the full screen here?
No, we are able to see the notes as well.
All right. Let me. How about now?
Yeah, it's the full screen.
All right, perfect. All right, perfect. So just a little bit on me. I am Professor Matthew Lanham. I'm an assistant professor of business technology and analytics at Butler University, and I'm the founder of this competition. We just finished the 4th year successfully, and a couple other hats that I wear. I'm the president-elect for the Informs Analytics Society, who's co-hosting this webinar today. If you didn't know about the Informs Analytics Society, well, I'd be really surprised by that, because we're the largest group within Informs. Out of all the different communities, we have almost 2,000 members. And when I used to lead the Purdue's UPS George D. Smith Prize winning analytics program, all our students were Informs members, and a lot of them became data mining society members, because I used to be the president for that group. but they also became Analytics Society members. I always ask them, I said, why'd you join the Analytics Society? And they said, well, obviously, because we're getting our master's in analytics. And I said, great answer. You're exactly right. So we just have an unbelievable community of practitioners, researchers, really the full gambit, where people are using analytics to make good decisions. So I don't have a slide on that, but if you just Google Informs Analytics Society, it's the first thing you're going to hit. So check that out. The other thing is I serve on the Informs Analytics Certification Board. That's the unit that basically houses the certified analytics professional. And I'll talk a little bit about that, which is the group that created the Informs Analytics Framework, which is part of this competition. So my spiel for the last part of this session, before we get out of here for Memorial Day weekend, is why should you participate in Data4Good? So just a couple things here that I suggest you bookmark so you can stay up to date after we get off this call. The first one is we have an official LinkedIn site. You can just, you can either use the QR code there, or you can use the link. But we also have a main competition site that's hosted on datacamp.com, who's one of our sponsors. The other link there that I'll have in all my slides at the very bottom is the bit.ly link, Informs 522. And there's also a QR code in the bottom right-hand corner of every slide. If you guys could just open that up now, I'd really appreciate it. There's just a few questions I'd like to get from the audience. One is, do you want me to follow up with you? Would you like to learn more about the competition? You have questions. That's a great way to get in contact with me and share your feedback. Maybe who's on the call or watches this video later, maybe you're a faculty member that wants to know how to integrate this competition into your maybe a data mining or predictive analytics type course. Let me, I'd love to share how I've done that over the years to make sure everybody in your whole class gets good outcomes. And then lastly, if you want to be a sponsor, that's another opportunity to use that bit.ly link to kind of connect with me. So what are we doing in Data4Good? Well, our mission is to provide college students and practitioners an opportunity to improve their knowledge, skills, and abilities of data analytics for good. And our vision for the future is to be the premier data analytics for good opportunity in the entire world. So this used to be designed just for college students, but we kind of opened Pandora's box last year by having a practitioners track. And we're hoping to really grow that for our Informs Analytics Society and Informs Practice Section community members, or anybody within Informs that wants to participate. So what are people saying about this competition? Well, most people believe that the competition was worth their time and money they invested. And 9 out of 10 said they'd recommend students to participate in the next year's competition. So we got outstanding, just above expectation feedback from the previous year's participants. Other things that we captured from our post-competition survey is 9 out of 10 believe this competition helped fill a knowledge, skill, or ability gap that they could use to showcase to employers, which, in today's market, that's something that you all have to be thinking about is, how do I stay up to date, and how do I show that, I need to be employed and they need to hire me. 8 out of 10 said that they would probably or definitely discuss their competition work in a future interview to highlight their analytic skills. 80% believe that their knowledge of the Informs Analytics Framework was moderate to advanced in level. So that was pretty big improvement outcome there. And then 9 out of 10 plan on using the Informs Analytics Framework in the future when they design and deliver analytics solutions. So just got some really great outcomes. What's the value proposition for this year? Why should you consider participating if you're a student, undergrad, or master's level, or you're a practitioner? Well, let me give you 4 key opportunities right here. The first one is we will offer the Microsoft AI 901. It used to be AI 900. That's phasing out this summer. It's going to be AI 901, but it's still the AI Fundamental Certification. That's a $99 retail cost if you want to pay for it outside this competition, but if you choose to participate, you can get that for only $25. That includes the proctoring, and you can do proctoring at home on your own computer. You don't have to go to a testing center or anything like that. So that's the first home run. The second thing is you're going to get free 6-month Data Camp subscription. So Data Camp has hundreds of courses on AI, dashboarding, machine learning, you name it. They have a full gambit for, they have a course for what you need, where you're trying to skill up for this year. You get a free 6-month subscription to do any of those courses. And if you're going to pay for that yourself, they're charging right now with a 50% discount, $164 per year to be a subscriber. Another home run that you're going to get is the Informs Certified Analytics Professional Essentials CAP-E prep course. So, the CAP Certified Analytics Professional is our certification for Informs members that want to differentiate themselves in the market. And we have just a real high quality prep course now. If you're going to pay for that yourself, it's $275 for non-members, $195 for Informs members, or $150 for student members. But you participate in our competition, guess what? You're going to get that whole course for free. And then last but not least, we also have a wonderful partnership with SAS, and they are going to provide some free training and opportunities to earn badges if you feel like that's something that you want to do. So right off the bat, that's a lot you're getting just for participating in this competition. I want to hit on a couple things. If you're not familiar with the Certified Analytics Professional, you can get all detailed information if you go to certifiedanalytics.org. But basically, there's 3 different tests that are designed for people based on where they are in their stage in their career. So people that are graduating like with their master's degree in analytics, like this, in data science, like this awesome Oklahoma State team that just participated, they would be perfect candidates to take the CAP-E, CAP Essentials exam, because they're literally masters of that Informs Analytics framework. I thought that was pretty crystal clear. But if you have some work experience, you're mid-career practitioner, maybe you're ready to lead some projects, you could choose to skip CAP-E. You can go straight to CAP Pro. And then lastly, say you're a senior leader, maybe you've worked for 5-6 years or more, you're trying to drive the strategy and organization forward, higher level, you can go straight to the final. You can't get any higher than that, is the CAP Expert, or CAP-X as we call it. You can take that test. So you don't have to take them in order. You could just go straight to CAP Expert if you kind of have that background. But what we're really trying to do is get people to differentiate themselves in the market, really master in the process. And that's what the Informs Analytics framework is. It is truly the gold standard for analytics processes. It's like building your house on a rock foundation instead of sand. So basically, you saw the team present their work following this framework. There's 7 domains, and this CAP-E prep course is going to have content on every one of those things to help you get prepared if you want to take that test. Okay. We also may have some opportunities to have discounts on these exams, but we can't commit to anything like that now. So, but I want to let you know there's no better resource to prepare for this CAP exam than this CAP prep course, which will be free for all people that participate. The other thing that we have, the value proposition, and this is particularly suited for the students, is a good case. A lot of our graduates, they're going to get great jobs and they're going to serve their organizations well. But honestly, most people aren't going to have a chance to really do something for good, once they get out into industry. So that's what we're trying to do, is give students an opportunity to kind of think beyond themselves, think higher level, bigger picture. And here's just over the last 4 years, here are the competitions that we had. When we started out, we were trying to do use natural language processing to create captions for children's books. And, these are in like some low resource language, some language maybe a few thousand people in the world speak. It was a really tough problem. And then in 2023, of course, large language models are out. We had a healthcare problem there. 2024, we worked with TAPS to help them identify when people had lost loved ones, what kind of stage of grief they were in. And they're still using that work today. And then this last year, which is just what the team just presented a minute ago, which is trying to understand basically reliability, factuality from these different AI tools. So we don't have the case set in stone now. We have a committee now working on it to try to get a case that really grabs that heart. That's what we want. Really grabs the heart, really gets you to think bigger picture and do good. And we're working on that. We haven't released that. But this reach continues to grow, right? So we always have big pot of money for financial prizes. And of course, we always get a lot of students across the country to participate. This last year, we had $31,000 we had raised from sponsors and prizes. 96% of the participants had passed the AI 900 certification based off the training that we provided. We had almost 300 teams. We had over 1,100 students. And then the real home run, and that was really due to our partnership with Data Camp that hosts this competition on their website. We had 105 universities. So we're really growing. We had 15 universities from outside the U.S. And we even this is when we kind of tested to see, can we include practitioners? So we had a track for non-students for practitioners last year, and we're going to kind of extend that this year. So, if you are in that practitioner group and you're like, I work 40, 50, 60 hours a week, I can't be building models and working on a case too. Don't worry. Our committee is working to come up with a special track just for the practitioners where you could do it. Maybe you have time to do that. But the main thing I bet you're really focused on as that practitioner is, how do I get access to that data camp? How do I get that $25 AI 901? How do I get some SAS badges? Or how do I get that CAP E? Those professional designations I know are probably going to weigh more for you than another problem. So we're working on that. But you might ask, hey, is this for me? So back to the students, is this for me? Do I even have a chance? Is this just for like the really smart kids from Oklahoma State? No, it's not. It's for everybody. So here's just some data that I got as we surveyed the students at the beginning of the competition. We're really getting a full spectrum of students. The premier, maybe 4.0 kids versus maybe even the 3.0 kids. And, as a teacher, as a faculty member, that's what we want. We want to try to make sure we're skilling up everybody in our audience, in our classroom, so everybody gets a good outcome. Even if you're not a regional champion or a national champion, everybody in our class is getting certified. They have a project that they can showcase and highlight to employers. They understand how to follow a process in their work. That's such a blessing. That is such a blessing. And I will talk a little bit more about that. Students perceive their skills to be even better after participating. So what we saw was very consistent perceptions of where their scores were. So statistically, it was very consistent, but then also the change from when we started the competition to when we ended, it was gains in basically all areas. So using like scikit-learn, using Seaborn for visualization, doing text mining, which was a key part of this last year's competition. But basically, there's a lot of areas that we surveyed them on, and all of them really felt like they improved in all those areas. A lot of participants completed 2 or more data camp courses. So, that 6-month free subscription you can take anything you want. And a lot of people were doing that. They were kind of picking and choosing those areas that they felt they were weak in or they wanted to improve in. And we didn't make people do that. That was just something that they decided to do. And they absolutely love data camp. So, so that's good. We're using a platform where they're finding courses that they feel actually helps them improve their skills. So we're so thankful for data camp. And the interesting thing is, because this isn't just a case, that's what you see in all these competitions. It's just a case. And there is value in a case, but we want more than that. So this competition is points based, meaning that you come to the AI 900 training session, you get points. You do the certification, you pass, you get points. You do these different things to get points, and the case is just like a third of those points. So it's not just the full gambit, and that's how you're going to get full like outcomes across the board on your team or in your classroom. The other thing, most students did this stuff outside of class, right? So what we're doing now, and I'll be holding some webinars this summer. Again, this is one of the questions. If you click the QR code or you do the Informs 522 bit.ly link, if you're interested in I'm going to do some webinars talking about how I integrate it into my class to get all my students certified, to get all my students to have a poster of their work. I'd love to show you how I did that, because that's the feedback that we get from students is when we asked them, would you have spent more time on this competition had your instructor at your university made the competition as a graded course component? Of course, right? So you're not asking them to do any more than they would have already did, right? So, as a faculty member, as a teacher, you're going to give them that first, exploratory data analysis homework in your data mining class. You're going to talk about your process model, maybe Informs Analytics Framework or CRISP-DM. Well, instead of just get them some random assignment, have them work on the Data4Good case. Have them build the models on the Data4Good data set, right? That's what we're doing. And you're not making the students, have to do all this extra work. You're kind of killing two birds with one stone. So I want to acknowledge the sponsors from last year. We're just so thankful for them. Thankful for ZTech. We're thankful for all the academic partners. A lot of these partners are going to be sponsors again for this next year. If you want to be a sponsor, please send me, fill out the bit.ly link, and to be a sponsor, we can talk about how we can get you on the website and highlight your sponsorship. So the very last thing, I only got 1 minute left, so I'm not going to go over on that. Actually, I just want to say that on the website shows all the outline for how the competition was last year. But bookmark that site, because we will be updating that with the new design, the new case, very, very soon. But I guess we got 1 minute left. Rajesh, do we have any questions?
You can wind it up, please, then. No questions.
No questions?
No. Oh, sorry, hold on. Let's see. Oh, there is one, I think. It says, could you put the website in the chat? So,
yes, I will. Let me put the links here in the chat. I already have them already up, ready for that. So here is the, let's see, here's the chat. So here's the LinkedIn site. Here's the Data4Good Data Camp site. And yes, so those are the two things there. But again, it was really nice to spend some time with you guys before we head off for Memorial Day weekend. So thank you so much, Informs, for hosting this event.
thank you, Matthew. And Patricia, if you have any closing comments, otherwise we'll switch it off.
No, I just would like many people to participate in the Data4Good competition. Thank you.
Thank you, guys.
Bye-bye.
See ya.
Bye.
Thank you. Thank you.
Thank you so much.